sorry.
Welcome to Klein's Geometry. Today we're going to talk about Lesson 10.1. Our objectives for this film are going to be to learn to classify three-dimensional figures according to their properties, and then we're going to use nets and cross-sections to analyze the three-dimensional figures. We're going to start, wrong way, you guys know how to do that. We're going to start by looking at a three-dimensional figure. Three-dimensional figures that we're going to be looking at, they can be made up of flat or curved spaces, but we're going to be looking at three-dimensional. We're going to look first at our polygons. Each of these flat surfaces, the top, the bottom, the two sides, here, or the front, right here, or the back, they're all called faces. Another way you might hear them described is bases. Bases are faces. An edge is where two faces intersect. It's these long stretches along here. And a vertex is anywhere that the edges meet. So the corners would be the vertices. Now, in a prism, we have two bases, and they're parallel to each other, and then we call them faces that go around the sides. So the faces that are parallel to each other, the top and the bottom, are called bases. In a cylinder, again, two parallel bases, the top and the bottom, and the sides going around. We'll talk more about what that looks like. They're curved in this, and we wouldn't call that really a face because it's not a plane. And a pyramid here, notice it comes to a point. There's only one base, and then the faces bring it up to a point, and this base is also a face. And a cone comes to a point with one base and the curved edges. Now, when you look at all of these are all polygons, and you think, how are we gonna name them? Well, we name them by looking at their bases. So notice this triangular prism, that both the base at the top and the bottom that are parallel are triangles. So, triangular prism. Here, the base at the top and the bottom that are parallel are rectangles, rectangular prism. Again, with pentagons, 5 sides, and there's one in the top and the bottom. Notice in this case, they aren't directly above each other. That's no big deal, but we call that oblique because they are not right above each other. This is not a right angle. This hexagonal prism, 6 sides on this base at the bottom and the top, so it's a hexagon. 2 bases, so it's a prism. And the bases are above each other, straight up and down, so it's a right hexagonal prism. Again, with the hexagon in the base, but notice it comes to a point here, so it's a hexagonal pyramid. Again, with a pentagon for the base, 5 sides, but it comes to a point. There's not a base up above it, so it's a pentagonal pyramid. Same with the rectangle, and same with the triangular pyramid. To classify the figure, first we'd look at this. If we thought all of these sides were exactly the same, we might call it a cube. Just like our dice is a number cube. But if we thought maybe these were bigger, different size than this, we might call it a rectangular prism. Either one would be correct. We'd have to say prism because it has 2 bases, a top and a bottom, as well as the faces. Now when you're naming vertices, you're just looking for the corners. A, B, C, D, E, F, G, and H. So name the vertices. We're just going to, well, they called it a cube. We'll just list the letters one right after another with a comma, because we know when you're naming a point, that's all you do. Edges, we're going to look at where the faces connect. So AB is an edge, BC, CD, AD. Other edges, if you think about the base, down in the bottom, EF, FG, GH, and EH. So now we've got 8 edges so far, but look, here's 4 more. A to E, B to F, C to G, and D to H. So those are all our edges. One method that I've told people for years works so you don't forget any. First, name the edges around one base, then name the edges around the second base, and finally connect those 2 bases and you should get 4 more edges. So altogether you've got 4 edges up here, 4 more, and 4 more, so 12 edges. When you're talking about naming the faces, you're looking at the top, A, B, C, D. You can name that. And the bottom, E, F, G, H. You can also name the sides, A, B, F, E. Remember, name them as we trace them. And then the back, B to C to G to F. This side, C to D to H to G. Name it as you trace it. And then the front, A to D to H to E. So you can name those also as you trace them. And there's going to be 6 sides, top, bottom, front, back, left, right. So you'd have 1, 2, 3, 4, 5, 6 faces on this 3-dimensional prism. Now you look here, another 3-dimensional object. Think about it. Prism or a cone or a pyramid. Think. Comes to a point, pyramid. How many, what does the base look like? 1, 2, 3, 4, 5 sides. That's a pentagon, pentagonal pyramid. Now, name our vertices. Just our points, A, B, C, D, E, F. Just name them with the comma after them. Name our edges, everywhere the base meets. And one nice way to do this is first just go around your base, A, B, B, C, C, D, D, E, A, E. Now, get all your edges up to the top point. A to F, B to F, C to F, D to F, and E to F. So when you come into a point with a pyramid, you have as many edges around the base as you've got, and then double that because you're going up to this top point. And those are all segments. The only base you have is this one, A, B, C, D, E. The others are all these sides are faces. Now a net is a diagram of that surface. It's 2-dimensional, but you could fold it to make the 3-dimensional object. And to identify a 3-dimensional figure from the net, look at the number of the bases, the shape of each face, see how you could fold it in. Imagine it folded up. Now let's take a look at this net. You see it's got 2 bases, 4 faces. What could it be? Well, if you look at this cube, you'll see 2 bases, 1, 2, 3, 4 faces. And if I untape this, you see exactly the same net in a smaller version. So this would be a cube. You look at this triangular pyramid, and I call it, notice the base is a triangle. You could fold all of these up and they'd come to a point. Not unlike this pyramid. Triangular base comes to a point. I untape it, and you can see you've got the same thing. You've got a triangle down here, one here, one here, and one here. So that's where you'd get a triangular pyramid. This is a little trickier. It's hard to visualize this, but what would happen here if you think about a base, and how would this curve around the base? Well, it would actually form a nice little cone here. So I could take this cone apart, and you'll see exactly this net, where this curve came right around here and around the other side, and it gets you that nice point. So this is a base, the sides, and you get a cone. And the last one we're going to look at, I see 2 bases, so I know I've got some sort of a prism, and this rectangle, this one face, so you know it's going to actually be a curved surface, and it's going to end up, if you fold it up, to look like this cylinder, like a pop can, like the Diet Coke can you see me with every day. Notice we end up with the sides fold into this nice rectangle where this length of the side is the same distance around as this base. So it's actually going to be the circumference of the circle, 2 pi r, something to remember for later. And you have your 2 bases, and there's your rectangle. And the width of this rectangle is the height. So we have a cylinder there. Now cross sections, this is where the video gets a little bloody. It's the intersection of a 3-dimensional figure and a plane. So describe this cross section. Now let's take a look. We have a pyramid. We have a plane. Here's my plane. It's actually a pie plate. And if I just set the pie plate on top of that, what is the intersection? What do they have in common? And they only have that one point. So the cross section would just be a point. But what if I took this nice cone, nice innocent cone, not doing anything terrible, but I'm going to intersect it with this knife now. And what I'm going to do, because I'm going to slice it this way, this would be perpendicular to the base. And we're wondering, what would the cross section look like? Well, the cross section is what you see after you slice it. And so you'll see a triangle. So cross section, when you slice perpendicular to the base, is a triangle. Now what if I took this same nice innocent little cone, and instead of slicing it perpendicular to the base, I sliced it parallel to the base. So I come across that way. Well, let's do a little surgery. Slice it parallel to the base, and you will see that it's going to have exactly the same shape as the base. So if it was parallel to the base, we're going to get a circle in this case. Now, let's look at one more figure. They're talking about a piece of cheese here. Notice I have pink cheese also. Port wine, the best. Let's cut this parallel to the base. And what do you think we're going to end up with? Take a second. I know the suspense is killing you. And yes, it is a triangle. It is the same shape as that triangular prism. But what if I want to make a rectangle? Because I have rectangular cheese. Well, I know parallel to the base isn't going to do it, but I could cut it perpendicular to the base, and I get a nice rectangle. Fits my cracker very nicely, and we're all set. So cross sections, remember that's how you're going to describe them, perpendicular to the base. What are we going to get? And the clue on how to do these questions are so easy to answer. When they give you this picture, you look, okay, look at what they've outlined here. You can clearly see you've got a rectangle, so you're going to get a rectangle from the cross section. Let's take one more look at this one. Here you can clearly see where they've outlined it for you. You cut it, there's a triangle. You're going to get a triangular cross section. So we have talked what the shapes are. If you have 2 bases, call it a prism. If you have, or a cylinder. If you have 1 base, call your 3-dimensional figure a pyramid or a cone. And if you're talking about a net, think, how would I fold that to make what shape? And if you're talking a cross section, what's it going to look like? Parallel to the base, it's going to be the same shape as the base. That said, this is the classwork you're going to be doing for tomorrow. And if you need more information, refer to your book.